Alright, this was actually a test on exponential and logarithmic equations, and I'm going to go through this one problem at a time. Please put your pencils down. Do not copy me while I'm doing this. The best thing for you to do if you don't understand a problem is to watch me do it, see if you can understand, but then go back and do it yourself, and that's the only way you really know if you know how to do it. Problem number 1. We're supposed to solve this. Now I'm seeing the 7 and the 49, and like bases can be done with this problem. So let's do like bases. So I've got 7 to the 2x minus 20, and 49 is 7 squared, like bases. Then I can set the exponents equal to each other. So 2x minus 20 should equal 2. Let's add 20 to both sides. So that tells me that 2x is equal to 22. And then we would divide both sides by 2. Alright, that tells me that x is equal to 11. Alright, number 2. Now, we have these bases and we're multiplying. When you multiply two things with like bases, you add the exponents. Think about it. If I had n to the 5th power times n to the 3rd power, what would you get? Hopefully you know that that's n to the 8th power because you add. Well, that's the same thing we're doing now. Alright, so I will have 5. 5 does not go away. But 2x plus x is 3x. 1 plus negative 2 is negative 1. And that is equal to 2. Then we have to rewrite this in log form to get the exponent out of here. Start with the base, 5. So we write log base 5. Now, these two things are going to change sides. So the 2 is going to come over here. This is not an exponent anymore, okay? Log 2, it's all on one line. This is not a power, okay? Anyway, so the 3x minus 1 is going to come over here. Alright, so we just need to get x by itself. So we've got to keep working. Let's add 1 to both sides. So that's going to give me log base 5 of 2 plus 1. Alright, you can't add these and make 3. You just got to leave it on the end. Is equal to 3x. Now we have to divide by 3. Okay, to get rid of the 3. So, got to divide everything by 3. So those 3's cancel out. So that's going to have x by itself. Now, this is still not 100% ready to type into the calculator because of this log base 5 of 2. There's no way to directly type that into the TI-30. So we need to use our change of base formula. Alright, so we're just focus on this part right here. And I can write that as log 2 over log 5 plus 1. And let me keep this in green so that it's easy to follow what I'm doing, because all of this is still over that 3. Alright, so now we're ready to type this in our calculator. Now I like to type it all in at once, like this. Now you see that 3 is in the denominator, so there's 3. Now in the numerator I have a fraction. This blue stuff starts with a fraction. So now I can do my log 2 and then over log 5. And then, whoops. And then plus 1. Okay, kabam. So you have 0.48, round up. Now, just real quick, another way you could have typed that in your calculator. Some kids are not comfortable typing it all in at once. So you could have done like this, just sort of following the flow of the problem. You could have done log 2 divided by log 5. You'll notice I'm even using the old-fashioned division sign from elementary school. So I hit enter. I have this so far. So far that's just this fraction. Then I would have to add 1 to that, so I just hit plus 1. Make sure you don't round, no rounding mid-problem. Hit enter again, so I've got this. And then I still have to divide by 3, so I just go divided by 3. Okay, and as long as you didn't round in the middle of the problem, you're going to wind up with the same answer we got the first time. Okay, so you do it whichever way you are best at. Alright, some problems we have log on both sides, and some problems we only have log on one side. When you have the log on both sides, like we do here, you can drop those logs out, okay, and just go 3 minus 2x must be equal to x minus 9. I mean, the logs have to be the same kind of log. So now we're back to math 1. So I would get the x's together first by adding 2x to both sides. So that'll give me 3 equals 3x minus 9. Then I might add 9 to both sides to get rid of these 9's. Okay, so that's going to give me 12 is equal to 3x. Okay, then I will divide both sides by 3. And I will get x equals 4. Okay, now anytime we're dealing with logarithms, we have to pay attention to whether or not our solutions are extraneous. That means we have to look and make sure we won't get a negative number if we plug it back in. And I think this is going to be a problem. For example, if I say if I put my 4 right here, okay, then that's 4 minus 9. Well, that's negative 5, so I have the log of a negative number. That's illegal. So right away I know this is extraneous. You see it also over here. If I did 3 minus 2 times 4, that's 3 minus 8. All right, again, that's negative 5. It's great that they're the same, but it's a problem that they are negative. So we are going to cross this out and put extraneous. Okay, and sometimes we have two solutions and one of them is extraneous, and then we just write down the other one. But if our one and only solution turns out to be extraneous, what do we put on the answer line? We put no solution in that case. Okay, so number 3 has no solution. All right, number 4. Notice that we only have logs on one side. So I'm not going. These logs will not just disappear like they did on the last problem. You can only do that when you have the log on both sides of the equation. Yeah. All right, so on this one, what will we do? First of all, we need to condense this. All right, remember that, like, say if I had log base 3 of A minus the log base 3 of B. If we condense this down to one log, subtraction condenses down to division. Okay, log A over B. So that's what we're doing, except for a is x squared plus 8 and b is 4, but it's got to be a over b. So that's what we will do. Again, the log does not go away. So I have log base 3 of x squared plus 8 over 4, and that's equal to 3. Now it's time to rewrite this in exponent form. Okay, starting with the base, bring that down, so the base is 3. All right, now the rest of this is going to have to change sides. So all of this and the 3 are going to trade places, sort of. I say sort of because when the 3 comes over here, it suddenly becomes an exponent, even though this was not an exponent. Now this is going to come over here to the right, so this will be x squared plus 8 over 4. So this is what we have. No log. Once you go to exponent form, there is no log in exponent form. 3 to the third power is 27. Okay, to get rid of this fraction, we can multiply both sides by 4. All right, so those are going to cancel out. Let's see, I think this is 81, but let's check. 4 times 27. 108. See, I would have been wrong. All right, 4 times 27 is 108. So I have 108 is equal to x squared plus 8. All right, because we just have x squared, I can get it by itself by subtracting 8 from both sides. Okay, that is going to give me 100. So that gives me 100 is equal to x squared. And then I will take the square root of both sides. Hold on. Shooting for green this time. All right. And anytime you take the square root of both sides, don't forget that your solution will be plus or minus. There are two solutions. So the square root of 100 is 10, but this is plus or minus 10. Okay? Now please understand that this is two separate answers. This means x equals 10 or x equals negative 10. And you need to check them separately and make sure that neither of them are extraneous. Well, this is the only variable. If I put 10 here, I get a positive 100. If I put negative 10, I still get positive 100. All right? Because squaring something, yeah, a negative times a negative is a positive. So both of these work. So we have to write them both down. So x equals 10, x equals negative 10. If you wrote plus or minus 10, that's okay. Let's look at number 5. Okay. Well, this 7 in the front is weird. The easiest thing to do would be to divide. Now, I could have put the 7 up, and I guess theoretically I could have done this to the 7th power, but talk about the long way. That's not what you want to do. What you want to do is divide both sides by 7. All right, much quicker. So this is going to give us log base 5, 3x minus 50 is equal to 2. Once again, notice I only have log on one side, so it's not going to go away. Instead, I need to rewrite this in exponent form, starting with the base. So bring down that 5. All right, and now these two parts are going to change sides. So I'll have 5 squared equals 3x minus 50. All right, so that's 25. All right, I would add 50 to both sides now. All right, so that's 75. And then divide by 3. Okay, so that is 25. All right, got to make sure that this does not give me any negatives when I plug it in. All right, so 3 times 25 is 75, minus 50 is 25, so that's okay. All right, number 6. All right, check it out. Notice I have logs on both sides. So at some point, these logs are going to disappear. But first, we need to condense. Again, remember that if I had log A plus log B, all right, this would condense to log AB. Now, when I write AB like this, understand that this is multiplication, A times B. So that's what we're doing now. So we'll have to do x times x minus 6. All right, so I have log, I'll just show it for one more step here. We'll have log x times x minus 6. All right, equals log 16. Might as well drop these logs out now. All right, so those logs are going to go away. I'm going to be distributing here, so I'm going to have x squared minus 6x is equal to 16. Subtracting 16 from both sides. And I've got x squared minus 6x minus 16 is equal to 0. Okay, time to factor if we can. Now x squared is x times x. 16, it could be several things. It could be 4 times 4. Or it could be 2 times 8, or it could be 1 times 16. We need the inner and the outer to make the middle, so we're shooting for a -6. So I'm going to take a good hard look at 2 times 8 first. All right, so 2 times 8. Now look, inner, I have 2x. Outer, I have 8x. Can I get a -6 out of this if I pick the signs right? Yeah, if I had a +2 and a -8, that would make -6. So here's my +2, and here's my -8. But I do not stop there. Okay, I keep going to find x. I'm going to set these two equal to 0. So I will do x plus 2 equals 0, and x minus 8 equals 0. Here you would subtract 2, and you've got x equals -2. Here you would add 8. So you've got x equals 8. All right, now it's time to see if any of these are extraneous. Well, yeah, the -2 is automatically extraneous because this first term is just a naked x with nothing else with it. So if I do log of x, okay, that's the log of -2, and you cannot take the log of a negative number. So -2 is extraneous immediately. So I'm just going to cross that out and write extraneous. All right, how about the 8? Well, it's positive, and then 8 minus 6 is +2, so the 8 is okay. So that will be my one and only solution to number 6. All right, I have lunch duty, and that was the bell, so I'm going to head off and watch and see if kids are throwing trash on the ground in the picnic area, standing on tables, throwing things at each other, you know, the usual. Number 7, got to get this e business by itself. So let's add 7 to both sides. So that's going to be e to the 7x minus 5 power is equal to 15. We need to rewrite this in log form. So start with the base, only it will be log base. So we will have log base e, and then these two things are going to switch sides. So I'll have 15 equals 7x minus 5. Now you know we don't write log base e, that's natural log, so go on and do what you're supposed to do and just put natural log 15. Okay, act like you got some sense. We still have to get this x by itself, so let's add 5 to both sides, like so. So I've got natural log 15 plus 5 is equal to 7x. Alright, now we divide. You can't add these, by the way. No natural log 20, please. So these cancel out. And this is really the answer. This is where we go ahead and put things into our calculator. And I like to just type it all in at once. So I would go natural log 15 plus 5 in the top, and then over 7. So that is going to be 1.10. All right, what number is this? All right, this is number 7, 1.10. All right. Number 8, solve the inequality algebraically, okay? We can do like bases here. So this is 3 to the x minus 2 power. Yeah, we're going to solve this inequality by looking at the related equation. 27 is, of course, 3 to the 3rd power. So that would give me x minus 2 is equal to 3. If I add 2 to both sides, that's going to give me x equals 5. Now, that is not the answer. This is an inequality, so it'll have many, many answers. But this will give us a critical value that we need to solve this out. Go to the number line. So x equals 5 is going to be a critical value. We'll put that on our number line. I like to just put it right in the middle. Okay. Now, will this be an open circle or a closed circle? Because it's or equal to, we'll make it a closed circle to show that the endpoint itself is included as one of the solutions, the equal to part. Alright, now it's just a matter of will the solutions be to the left or will they be to the right. To figure that out, we're going to need a test value. Okay, you can use any test value you want other than 5. You could use 0. I'm going to use 2. Because if I do 2 minus 2, that'll make 0, and that's going to be a really easy value for me to think about. Okay, so that's what I'm going to do. So I'm going to test x equals 2. But again, you can use any value you want. If I test x equals 2, that means I'm plugging 2 back into the original equation. So that would make this 3 to the, not x. X is 2 now. So 3 to the 2 minus 2 power is greater than or equal to 27. I don't know if this is true or not, so I'm putting a question mark on it. That makes this 3 to the 0 power is greater than or equal to 27. Anything to the 0 power is 1. 1 is greater than or equal to 27? I don't think so. So that's a fail. That's a big no. So I just did a test value of x equals 2. Let's see where that is on my graph here. So x equals 2, you know, is around here somewhere, depending on what your scale would be. But 2 is definitely on this side. And so that was a no. That means this must be the yes side over here. Alright, so this side is where all the solutions will be for this inequality. Okay, so there's my graph. And but I'm also supposed to write the solution in interval notation and put it here. So 5 to infinity. I will use a squarish bracket similar to the closed circle. This means 5 is included as one of the solutions. Okay, 5 to infinity. So this is what your complete answer to number 8 should look like. Every time I finish a problem, I have to fight the urge to ask any questions. All right, did I lose anybody? But then I remember you're not really here. Not really. At least I can't hear. You're here, okay? You can't. If you're listening to this video, you're right here. But I just can't hear your questions. Number 9. So okay, same type of thing, but we are not going to solve it out by hand. We're going to judge it from the graph instead. So we don't have to do any calculations, no test values or anything like that. So we just do this. When we look at this symbol, are we thinking above or below? Yeah, we are thinking below. Okay, because that's less than, so we're thinking below. So I like to just highlight the part of the curve that is below, and think about it. This is saying the function, where's the function below 2? And see the red line, see how it's at 2? So where is the function below 2? Well, that should be pretty obvious, that this is where the function is below 2. All up in her. Okay, that's the part of the function that's below 2. Now, in terms of the critical value that we're going to put on our number line over here, you can see that the cutoff point here is this point, all right, where it crosses the red line. But you got these two numbers, 9 and 2, so you have to be aware of which one of these you're going to use. Now, this number line, is this set up like an x-axis, or is it set up like a y-axis? Do you know what I'm talking about? I hope you do. This is the x-axis, right? And this is the y-axis. So when we do a number line like this is just like the x-axis. Okay? We're looking left to right, like the domain. So I said that to emphasize that what we need is the x value. All right, we're not doing a y thing. All right, we're not going vertical with it. We're doing an x thing. Okay, so we need the x value. So it's 9. That's the critical value here, not 2. So we'll put 9. Again, this will be a closed circle, okay, because it is or equal to. Had it been just less than, like if this weren't there, then we would do an open circle. Alright, so all we have to figure out now is, will the solutions be to the left or will they be to the right? Well, instead of doing a test value, we're going to use the graph. And you can see the part that we highlighted, alright, the part that we decided was below 2. Is this going to the left or is it going to the right? Well, you can see that it's going to the left. So that's where our solutions will be. To the left. Okay. Now, am I going to go all the way to negative infinity? look back at that graph again. Is this graph going to negative infinity? No, it is not. Okay. The reason why, asymptote. Bam. Yeah. Logarithms, logarithmic functions, have a vertical asymptote, and when there's no shifting happening, nothing being added or subtracted, that asymptote is right here at 0. So that's why it's curving and swerving and not crossing this line. So this will not go all the way to negative infinity. It's going to stop here at 0. So you must reflect that in your graph. Okay, so you put 0 wherever you want over here to the left. You're going to have to make it an open circle because asymptotes, the way they work, you never get there. So you can't include 0 as one of your solutions here. Okay, so it's going to be from 0 to 9. So these are the solutions. So we will go 0 to 9, showing the solution set. Alright, so that's what your answer number 9 should look like. Let's find number 10. Okay, find the inverse of the function. Alright. So this is basically y. So there are two main steps to finding the inverse. Switch x and y, and then you solve for y. If I switch x and y, I will have x equals natural log 5y. Now I got to solve for y. To solve for y, I need to write this in exponent form. Alright, please understand there is an invisible base e when you're dealing with natural log, and we're going to have to use that. So exponent form, you start with the base. Alright, so bring down that e, and there it is. Now the 5y and the x are going to change sides. So the 5y is going to come over here. The x is going to come over here, but it will be the exponent. Okay, getting y by itself, we will just divide by 5 on both sides. Okay, so this is the answer, like y equals e to the x power over 5, but since it's an f, we'll put the f back in. So we will say f of x is equal to e to the x power over 5, but we'll make it the inverse by putting this minus 1 on it. So f inverse is e to the x power over 5. Okay, then we just look for that among these multiple choices. E to the x over 5. Uh-oh, did I mess up? Oh, okay. Yeah, e to the x over 5 is the same thing as 1/5 e to the x power. I hope that the difference between the way these look, I hope that didn't throw anybody off. You can picture an invisible 1 in front of anything. So you see this is 1/5 e to the x power. It's the same thing. Okay, so that's C. Yeah. Kabam. Alright, number 11. Which of the following is equivalent to this expression? So clearly we are expanding. When you expand, we're going to break this apart into a bunch of terms, adding and subtracting. Every factor in the numerator is going to turn into a positive term. Every factor in the denominator will turn into a negative term. Okay, so I'm looking at 3 terms here. One will come from this, one will come from this, and one will come from this. Okay, the 2 blue ones are going to be positive because they're in the numerator. The the pink one is going to be a negative term. Okay, so first the two blue ones. I will have log x squared. Keep it positive. Now the next one, plus log y to the third power. Alright, both of these you see are positive. Now the last one, because it's from the denominator, I will make it a negative term. So minus log z to the fourth power. Alright, all that's left is putting these exponents in front as coefficients. That's one of our log rules. So this will become 2 log x plus 3 log y minus 4 log z. Look at it, it's right there. Beautiful. That was fortuitous. So yeah, D is what it is. Alright, number 12. Doce, for my Spanish speakers. What is the condensed expression for this right here? Okay, so we're just going to condense this. When you're condensing, these coefficients will become exponents first of all. So you've got natural log x squared plus natural log 3. When you're condensing, addition condenses to multiplication. So this would be natural log 3 x squared, just multiplying those together. And you can see it right there, so that's C. Alright, trece. Alright, we need to write a model for the following problems and use your model to solve. No credit will be given for answers without algebraic support. Alright, nearest hundredth. No using the table function of your calculator. Alright, we want decimals. None of this. Oh, it's about 12. Nah, it's 12.31 years, like that. Okay, anyway, you deposit $3,000 into an account that earns 5.5% annual interest compounded quarterly. Alright, that word right there is a key that lets me know which one of these formulas I'm going to be using. Quarterly is telling us that we are compounding 4 times a year. N equals 4 in that case. So we're using the formula that involves compounding at certain intervals. Quarterly is 4, semi-annually is 2, monthly would be N would be 12, daily N would be 365, weekly N would be 52, that type of thing. Alright, if they mention how often it's compounded, then it's going to be this formula. Alright, if they say continuously, then it's the Pert formula. Okay, so we know we're using that formula. So that formula is y equals principal times 1 plus the rate over n times nt. So let's substitute in what we have got. It's saying we deposit $3,000. Alright, that's the initial amount, so it's got to go here for P. So here I've got my $3,000. And then it's 1 plus the rate. Okay, this rate as a decimal would be, you got to move this twice. So that's going to be 0.055. Alright, the N is 4 because of the quarterly. Okay, so this is the model. Make sure you leave T as T. If you plug in some number, like I'm not sure what you would plug in, I don't even know. but if this is the model. Now I'm going to look and see if this will make a nice easy decimal, a finite number, or if it runs off my calculator screen. Okay, so let's check it out. So I've got 1 plus over 4. It's not too bad. I'm going to write that down. So it's 101,375. Alright, let me just double check that because of my bad short-term memory. Alright, 1.01375. 1.01375. Alright, it would be nicer for me if this was even shorter, but it's okay. So I'm going to use this form of the multiplier here instead of writing 1 plus in the fraction. This is just will be slightly easier for me to work with. It doesn't matter which one you want to do, but this is just easier to type in. Alright, so the important thing is no rounding. You have to just use, if you're going to use it, you have to use all the decimals, all of them. Okay, so anyway, how long will it take for your investment to triple? So look, if it says we have $3,000 now, if the investment triples, how much money will there be years later? Yeah, it's going to be 9,000, alright? 3 times 3,000. So that's your y value, alright? The amount you'll have years later. So when you go to reset up the formula, you will just do 9,000 equals, and then you type the rest of your model. So 3,000 times, and again I'm going to use my little decimal there, 1.01375, okay, to the 4t power. Remember, okay. So now I just have to solve this for t, and that will answer the question how long. Don't multiply these together. That would be a big mistake. You want to divide by 3,000 on both sides. Alright, that way these cancel out. Now you knew ahead of time what this was going to be. This is going to be 3 because it said triple, and so that's tripling. So I have 1.01375 to the 4t power. Now some kids want to think they can divide by this decimal or something to get t by itself. You can't divide to get rid of a base. What you need to do is rewrite this in log form. Alright, that's why it's in this logarithm unit that we've been working on. So in log form, to switch, you always start with a base. So in log form, of course, we'll have log base. The base goes here. So log base 1.01375. Okay, now the rest of it is going to trade sides. So this 3 and the 4t are going to change sides. Alright, so I will have the 4t here and the 3 will be here. Notice this is not a power, it's on the same level as the log. Anyway, so now I need to divide both sides by 4, and there I will have t by itself. Okay, so that's going to give me t equals this right here. Now you will need to do your change of base to get this done. You can't type this directly in your calculator, so this blue part up here, you have to type it as log 3 over log decimal. So I will do log 3 over log decimal. Okay, that's the numerator. That's how you do the numerator. Now the denominator, and I'll keep it the same color just so you can track what I'm doing more easily. Okay, I've still got divided by 4, right? That didn't change. So, it's time for the calculator now. Let's see if I can move this all the way over. So I need to get this in my calculator somehow. I'm going to do it 2 ways. You can choose which way you want to do it. I usually prefer to type the entire thing in the way it looks all at once. So I'll start with the denominator to make it more obvious. The denominator is 4, so put 4 in the denominator. Now the numerator is a fraction, so in the numerator you need to hit your n over d button to make a fraction in the numerator, and then you type in the rest of it. So that's going to be log 3, and this is going to be log 1.01375. Okay, now I've typed it in. It looks just like this. It's a thing of beauty. So, kabam. So I've got 20.11. Alright, nearest hundredth, that's 2 decimal places, please. So that's your answer, 20.11. So I'm going to go ahead and write that down. And so we're talking about years. Alright. When you're doing a word problem, you should use units. Alright, so that how long? 20.11 years. So it's about 20 years, but you're not allowed to write about 20 years. I want the decimals. Okay. Oh yeah, I was going to show you the other way of putting this in your calculator. Alright, so if some kids get mixed up when they're typing this in and they wind up putting the fraction in the bottom, and that's wrong. So the other way to do it would be to just do it in stages. So you could go, for example, log 3, and I'll even use the old-fashioned divided by sign. So log 3 divided by log 1.01375, and hit enter. Okay, so I've got this decimal. I'm not going to round it, but I know I still need to divide by 4. So I'll just go divided by 4. Alright, and I get the exact same answer. Okay, so you do it however you feel most comfortable. Okay, moving on. 14. Alright, you deposit $5,000 into an account that earns 4.3% annual interest compounded, bam, continuously. Right away, that tells me we're going to use that Pert formula. Okay, so let me set that up. So I'm saying Pert, I'm talking about y equals p e to the RT power. Alright, this is the one we have to use. Okay, so you deposit. Boom. So that's the initial amount. So that's our principal. That's what P stands for. The original amount in finance is called the principal. So $5,000. The rate, we know that as well. So this would be 0.043. Again, you got to move it twice. Put a 0 in there. So we know that. Okay, 0.043 t. So this is the model. Okay. Now the question we're being asked is how long will it take for your investment to double? All right. Again, if it's 5,000 now, if it doubles, what will it be? All right. Obviously, it'll be 10,000. So that'll be your y value, because your y value is the amount you'll have years later. So as we set that up, then we have 10,000, right, okay, is equal to 5,000 e to the 0.43, whoops, there's another 0 in there, 0.043 t. Okay, so how long? So we're looking for t. Okay, so we need to divide by 5,000. Faux shizzle. Okay, so that's going to be divide by 5,000. Now we know what we're going to see. We doubled, so this is going to be 2. All day, every day. So 2 equals e to the 0.043 t power. Okay, I can't divide by e. I need to rewrite this in log form. So when you do log form, you start with the base. And normally we write log base, okay, like log base e. And then we take the other two things, like this, and they trade sides. So, so this 2 comes over here, and this decimal comes over here. That's normally what we do. But come on now, get serious, people. We don't write log base e. What do we write? We write natural log, okay, because that's what natural log means. So let's do that. Okay, so we're trying to get t by itself, so time to divide. We will divide both sides by 0.043. Okay, so those will cancel out, and that's just going to leave our t. So this can just easily go into the calculator. Whoa, wrong button. Okay, so natural log 2 over 0.043. Okay, so that's 16.12, round up. So that's the answer. And again, this was years. Alright, so that was number 14. Alright, so let's get on down to number 15. Maine had a population of 1.2 million, alright, which of course is this, in 1995. Since then, the population has increased at a rate of 1.3% per year. Write a model to estimate the following information. Okay, we're writing a model. Now this is not compound interest, this is just simple growth. So we're going to be using the formula that goes like this, just like y equals the initial amount times 1 plus the rate to the t power. We're using this formula, just simple growth. Okay? So the initial amount, the initial population is 1,200,000. I might need a little more space. Okay, so I'm going to have my 1,200,000. Alright, this is going to be 1 plus the rate. Well, here's the rate. Again, you got to move that decimal twice. So I need a 0. So this will be 0.013. Okay, to the power of time. Now, 1 plus 0.013 is just 1.013. So please understand that that is what I will be using, 1.013. Okay, so first of all, what is the current population, assuming this trend continues? I'm not going to put in 14 or 2014. This initial population that we're listing here was in 1995. So t is how many years have gone by. So it's a matter of how many years has it been from 1995 to 2014. Well, obviously from the year 2000 to 2014, that's 14 years. And then to go back to 1995, that's another 5 years. Okay, so that's a total of 19 years. Okay, if you're one of the people that could not follow what I just said, then you would have to subtract and do 2014 minus 1995, and you get 19. Okay, so 19 years have gone by. Okay, so t is equal to 19. So we're just going to plug in 19 for t. Okay, that is all. Notice in the model you do not plug in the 19. You leave it as t for the model. If you put in the 19 right here, you're losing points. Okay, you just use it to find the answer. So here we go. To find that answer, we go to the calculator. Okay. Alright, I'll just go ahead and just keep it like this. So I've got 1,200,000 times 1.013, and this is going to be to the 19th power. Okay, so I get this. Alright, we will round this to the nearest whole person. Alright, so this is 6, so we'll round this up to a 2. But, let's see, so I've got 1,533,772. Alright, that will be the population today. Alright, that's our estimate anyway. Okay, great. That's just great. Now, the tougher question, when will the population reach 2,500,000? Okay, well, this is the eventual amount years later, so this is the y value. So this is similar to the problems that we did before. So we're going to put in the 2,000. We're going to put in the 2,500,000 for the y value. I don't think I'm going to need that much space. Let's see. So 2,500,000 equals, and then we're just plugging that into the model. So 1,200,000. 1.013 to the t power. So we are simply solving this for t at this point. Alright, so this is just like the many other problems that we've done during this video. So I'm just going to divide once again. Alright, to get this part by itself. Alright, now as far as just typing this into the calculator, please understand that I can cross out all these zeros. Alright, let's see, I got 2 more zeros here. So I can just divide 25 by 12. And I already can see what's going to happen here. If I divide 25 by 12, now first of all, notice I like to use my fraction button all the time for division, because that automatically gives me a fraction, a simplified fraction, instead of a decimal. So I'm going to use this fraction as my answer, and you can see 25 over 12, it didn't really change. Okay, and I really encourage you to do the same. So 25 over 12 equals 1.013 t. Now, if you did not do the fraction version, then you did 25 divided by 12, and you got this decimal. Now, this is not even the whole decimal. It continues, it's repeating. It just ran out of space. So if you round this, then you're going to get the wrong answer, just plain and simple. You are not allowed to round until the last step of a problem. So don't do it. Okay? Now, if you did this, please understand that you can hit the toggle key here and make the fraction. But anyway, long story short, you better use the fraction. Otherwise, that's why you're getting the wrong answer. Okay, so just like we've done many times, we're not going to divide right now. We're going to rewrite this in log form. Now, when you do log form, you start with the base. But you write log base 1.013. Okay, and then this fraction and the t, we're going to switch places. So I'm going to have t equals over there, and then I'm going to have 25 over 12 right here. So I would love to put this into my calculator, but I'm going to have to do a change of base to make this happen. So I'm going to have to write t equals, and I'll do this over this. So I'll do log 25 over 12 in the top, and then I will do log 1.013 in the bottom. Alright, should be easy enough. Okay, so log 25 over 12, alright, over log 1.013. Okay, so there you go, 56.83, round up. Alright, and that is how you do that. Alright, number 16. You buy a new car for $24,000. The value decreases by 12.5% each year. Okay, the model. So this is not compound interest or anything, so we will just use a basic decay model. Alright, so we're talking about just y equals the amount times 1 minus the rate to the power of time. Because it's decreasing, that's why we do the minus instead of plus. Okay, now of course the original amount is $24,000. Okay, the rate, moving our decimal twice, the rate is 0.125. Alright, to the t power. So this is the model. Now please understand, it will be more convenient if you go ahead and do this subtraction. So if I'm going to do 1 minus 0.125, that is 0.875. So let's do that. Alright, that is more convenient, so I'll be using the pink version of this multiplier. Okay, so anyway, when will the car be worth half its original price? Well, if its original price is $24,000, half its original price will be $12,000. Alright, and that will be the y value because that's the eventual amount years later. So the equation becomes 12,000 equals 24,000. And again, I'm using the 0.875 is more convenient for me. And I'm just solving this for t. Okay, so divide by 24,000. Alright, but you already know what this is going to do. Alright, it's supposed to be half of its original value. So this is going to turn out to be 1/2. Alright, if you wrote 0.5, that's fine. Yeah, it's the same thing. So it's going to be half of its original value. Alright, which is equal to 0.875 to the t power. So once again, for like the 4th time, we need to rewrite this in log form, not divide. So in log form, we always start with a base. So we're going to write log base. Log base 0.875. Then these two things will trade sides. Okay, so the t is going to come out here, and the 1/2 is going to be here. Okay, in order to put this in your calculator, though, you're going to have to do a change of base formula. Alright, when I say change of base, I mean that's when we write this as a fraction and we say log of 1/2 over log of 0.875. Okay, that's how you put this in your calculator. Okay, so log of 1/2 over log 0.875. So 5.19. Okay. Number 17. You deposit $1,000 into an account that is compounded continuously for 15 years. Okay, write a model for this. Okay, fine and dandy. This time we don't know the rate, so we're going to have an R in this model. So we've got y equals, or oh yeah, by the way, compounded continuously. So as soon as you see the word continuously, compounded continuously, you know that we are using the Pert formula, right? Let me move it over a little bit more. You know that we're doing Pert. So we're doing e to the r t power. Okay, so the principal, the beginning amount is $1,000. So that goes there. We don't know the rate, but the time is 15 years. Okay, this looks weird to me, so I'm going to write 15R instead of R15. Okay, so this is your model. Kabam. Now, that's the model. So, if you want to have $10,000 in 15 years, what interest rate do you need? As a percent, please. Yeah, so we want to have $10,000. So, that's our y value. Okay, the amount that you'll have years later is always the y value. So, this will be 10,000, okay, is equal to 1,000 e to the 15r power. So I'm going to divide by 1,000. All right. So you can see that this has almost been the same problem, you know, over and over again 4 times. So hopefully, if you know how to do it, then you're getting all these right. But unfortunately, if you don't know how to do it, then you're getting them all wrong. So you got to make sure you know how to do this type of word problem. Anyways, if I just sort of cancel out these 3 zeros, I see it's 10. So I have 10 is equal to e to the 15r power. Hopefully by now, we've done this so many times that you definitely see that we are doing log form right now. So log, you start with a base here, so this is log base e, and then these other two things are going to switch sides. Okay, so the 15r is going to come over here, and the 10 is going to come over here. Yeah. Now, we don't really write log base e. That is natural log. So that's what we should write. So we should do 15r is equal to natural log 10. Alright, forget about the base e and just put natural log. So we're trying to find the rate, so we're going to divide both sides by 15. Okay, well, and this is going to be the answer, so I might as well just put it down here. Well, I guess I do need, I'm seeing what's coming, okay? So let's go. If I do natural log 10 over 15, okay, I get this r value. So I've got 0.1535. Now, why am I writing down 4 decimals when normally I need only 2? 5, 3, 5. The reason is this is not a percent, okay? This is just a decimal. Alright, did we do a problem like this before? Yeah, right. When they gave us a percent of 12.5, we didn't put that into the problem directly. We turned it into a decimal, r equals 0.125. Now, the r value that we just found is this blue 0.125. We need to turn it into a percent, like 12.5%. So to do that, we have to move the decimal back over to the right. So that's what's happening now. So yes, this is r, but you were specifically asked to give it to me as a percent, please. So we're going to move that decimal point twice. So this is going to be 15.35%. So that's why I wrote down 4 decimals, so that even after I convert it to a percent, I would still have the 2 decimals that I asked you for. Okay. And I think we are running into the end of this lesson. Yep, okay, so that is the end. We have covered this entire test. I hope this was helpful. I forgot to say right at the beginning to put your pencils down. I should have yelled at you many times throughout this problem to if you're copying off of me, it gives you a false sense of that you know what you're doing, but really you're just copying off of me, and then when it comes time to take a test, all of a sudden you don't know what you're doing. So never do that. Go back and do it yourself. Well, it's too late now because it's over. I will see you on the next video, guys. Good luck out there.